Hi students, I will talk now about dimension analysis. The most important thing in this section is that I can't add different quantities to other. For example, this equation 4 is equal to 4. That is right in mathematics, but is wrong in physics, because the unit here is different than the unit here. The quantity here is different than this one. Also, the other equation, this one, 6 is equal to 4 plus 2. That's right, but it is not right in quantities. To make it right, I need to add 4 apples and minus 4 oranges. In this case, I can cancel these with these, and the total quantity will be apples. It is thing like this, but we will see now in our examples. I will talk here now. If you look here, if I have a time equation, this left side will equal to the right side, and each term of these terms must have the same quantity type, which is time, and the dimension of this quantity is time. Also here, if I work with length, all the terms should be length. If I work, for example, with mass, all the terms should be mass. Take this numerical example. If I have 10 kilograms is equal to 3.8 kilograms, which is right, plus 200 grams, it is a mass, which is right, plus 1.5 A multiplied by M, which is volume. So A is hide inside it some different quantities than the volume. This is meter squared, cubed, I'm sorry, plus 9.92 pound. Pound is also a mass, which is right quantity. Now I need all of these quantities be in the same language, be in the same unit, which is kilogram, and also I need them to be in the same quantity and dimension. I will talk about this now. 200 grams, I will exchange them to be 0.2 kilograms. We will know later how to convert units. This is the first term. Now the second term, I need to put 1.5 as 1.5 kilogram, but I don't know A multiplied by M cubed. I need it to be in kilograms. So A M cubed is equal to kilogram. I can divide it both the sides on M cubed. In this case, A's dimensions is mass over volume, and the unit for A is kilogram for a cube meter. The volume in cube meter, which is, we know that area is equal to meter squared in units. If we take, this is the unit. If we take this is x and this is y, then the area is equal to x multiplied by y. X in meters, y in meters, then the area in square meter, because area is equal to x in meters multiplied by y in meters, which is equal to x multiplied by y, and meter multiplied by meter, which is square meter. This is the area. If x equal to 2 and y equal to 3, then it will be 6 square meter. Also, the volume is equal, for example, this is the volume x, y, z. The volume is equal to x, y, and z, and the unit will be cubed meter, and the dimension is length cubed. We will see that later. And then now we have A is equal to kilogram for over cubed meter, and the last term 9.92 pound. We can convert and exchange pound to kilograms by multiplying by this number. We will see how to do that later. And I exchange now the number in the amount and the magnitude from pound to kilograms. So every 9.92 pounds is equal to 4.5 kilograms. Now I have all of the terms in kilograms. So 10 is equal to 3.8 plus 0.2 plus 1.5 plus 4.5, which is equal to 10. So the magnitude, which is the number in math, is equal on both sides. And the units, this one is kilogram, I'm sorry for that. The meters cubed here will cancel with this one, so it will be kilograms. This will not stay as in grams. It will be in kilograms. And from pound I exchange my unit to kilogram. So now the both sides has the same magnitude and the same unit. Now we need to look here about this table. We have these three quantities in physics, which are primary, and these are derivable. These are derived quantities. The length, the quantity of length, we can sample it by x, y, d, r for radius, s, and the unit is in meter, not in centimeter, not in yard, not in foot, and the dimension is length. So if we look at x or radius or a unit meter, it is a length. It is not a mass. It is not a time. Now, the time mostly sampled by t or tau. The unit is second, not hour, not a day, not anything else. It is the main unit in SI units is second. The dimension is time. The mass can be sampled by capital or small mass. The main unit for it is a kilogram, not pound, not gram. The dimension is mass. And we need to know that if we use this bracket notation, that is the meaning of that is we are talking about the dimension. The derived quantities like velocity or speed can be sampled by v. The unit is meter per second, and the dimension is length over time. The acceleration can be sampled by a in lowercase. The unit is meter per square second. We will see that again later. And the dimension will be length over squared t, time. The force or the weight can be sampled by capital or small f. Weight can be sampled by W. The normal force can be sampled by N, capital N. The unit is kilogram meter per square second, which is equal to Newton unit. And the dimension is mass multiplied by length divided by squared time. Now I will start to solve these examples. I will take this equation. I don't know if this equation right or wrong physically or in physics. Okay, I have here x. X is a length, so this is length is equal to v is velocity. The dimension of velocity is length divided by time. Multiplied by a time dimension. In this case, I can cancel both of these terms because this over 1, and the final dimension is length. So length is equal to length, which is right, and I can expect that this form of this equation is right. Now I will look to the next one. Look, I just exchanged between v and x. Now velocity, the velocity dimension is length over time is equal to length for x, and the dimension of t is time. Look at that. I can cancel L from here and from here. This will give me 1 over t is equal to t over 1. By this process, I can multiply them, so I can find that 1 is equal to t squared. Look at this. This is a number. It is a dimensionless. It is not time, not length, not mass. It is just a number. It doesn't has any dimension. But the right hand side is square time. In this case, I has a dimension quantity on the right and dimensionless quantity on the left, which give me a wrong response or wrong answer. So this equation is wrong, cannot be true physically in physics. Okay, let me see now the third equation. The time x here, not the time, I'm sorry, x is length, x naught is also length. I can put subscript for any of these samples. It will not exchange thing, just it's a name. Plus x is also a length. Time is time. Plus a. Look here, a is acceleration. It's meter per square second. It is length over a length. I'm sorry. Over squared time. Is this equation works? I think no, because this term is length equal to length. This is good. Plus length multiplied by time. This is wrong. This is also wrong. So this equation cannot be true in physics. Let us see the last equation. This one is right, I know that. Look, x, we will find this equation and work with it later. X is a length equal to length plus v from here. Look at this table. Length divided by time multiplied by time plus half. It is just like this number. It is dimensionless. Where's the number? This one. It is dimensionless. So I will not put anything for any number. I will just use the samples. A is acceleration. A, length divided by time, which is squared in this case, multiplied by squared t or squared time. Look at this. I can cancel this by this, because this is over 1 and this is over 1. Cancel this squared with this squared, and look at the final result. Length is equal to length plus the rest from this term is just length plus just length. In this case, length is equal to length. That's right. I can add length to length to length, but I cannot add length to length multiplied by time or mass or anything else. This equation can be true, and it is in physics. Also this one. But these are the second and the third are wrong. Okay. You can use and pick any equation from the book and try this technique using the dimension analysis. I will use this example from the book, page number 8. This asks me about some dimensions for A, B, C, and D. He tells me, or the question tells me, that X is a distance, V is velocity, A is acceleration, T is a time. I have 4 equations. A is equal to acceleration multiplied by time. B, I will work with this one at first. Okay, the dimensions of A is equal to the dimensions of the acceleration multiplied by the dimensions of the time, which is equal to, I can look at the table now. I am new in physics. I don't know a lot of these equations. I can cheat from any table when I am studying. Now, A, it is length over squared time multiplied by time. I am not checking here the equation is right or wrong, but I just looking for the dimension of the given sample. I can, this is over 1. Time here is to the power 1, so I can cancel this with the squared from the denominator. The final result will be length over time as dimensions, not a dimensions. I'm sorry about bad English. So that dimension of A is length over time. This is the first one. What about the second given equation, which is B is equal to V over T? Okay, using the same way, the dimension of B is equal to the dimension of V divided by the dimension of T. This is equal to, the dimension of V is length over T divided by the dimension of T. I can use this over 1, which is equal to length over time multiplied by 1 over time, which is equal to length over squared time. Look at this one. Length over time, from the table, length over time, it is a velocity or speed. This is velocity. This is, from the table, is acceleration, which is acceleration. Okay? I can expect what is the sample denoted to. The third one now, C is equal to half X over squared T. Okay, the dimensions of C, look, is equal to the dimension of half multiplied by the dimensions of x divided by the dimensions of t squared. The dimensions of half is 1, not 0. If I put it 0, all of them will be 0. It is dimensionless. Multiplied by the dimension of x, which is length, divided by t squared. There's no meaning if that squared is inside or outside the bracket. So the final, now we have that dimensions is length over t squared, which is again like this, which is acceleration. Okay, the third one, d, is equal to dimensions of 2 multiplied by the dimensions of the acceleration and the dimensions of x, which is equal to dimensionless. The dimensions of a is length over squared t multiplied by the dimensions of x, which is length, over 1. Now I don't know why I'm changing the color, but I can multiply them in this way: length squared over t squared, which is equal also to length over t, all of them are squared. Length over t is a velocity. In this case, this is squared velocity. Please try many examples by yourself. If you have any questions, just send them to me, and thank you.